It's cold, it's windy. I'm standing at 4,500 meters altitude in the cold desert of Ladakh. The temperature is still a little warm at 2 degrees centigrade. Behind me is the Himalayan Chandra Telescope, the 2-meter class Indian telescope, a fine facility set up by the Indian Institute of Astrophysics. I first came here in the year 2000. So after that, I'm coming back to this facility with a long gap. Since then, great science has happened at the Indian Astronomical Observatory at Hanle in Ladakh. And to speak about this very unique location, I have with me Dr. Annapurni Subramaniam, a well-known Indian astronomer and director of the Indian Institute of Astrophysics in Bengaluru, and the site here is controlled by them. Dr. Annapurni.
Juley, namaskar.
Juley, what a pleasure to be speaking to you from the Mount Saraswati with the Himalayan Chandra Telescope and the wonderful facilities here. How do you manage the cold here for somebody who's a South Indian?
It is just the passion. Once you come over here, you forget everything. It's just the magical sky, and in the night it is like fireworks. You have so many stars and zodiacal light, and some things which you cannot see anywhere else in the world. I mean, anywhere else, at least in India. So it's amazing to be here, and it's hats off to our predecessors who actually selected this site. There are a lot of uniqueness about the site and why we are here and doing this, overcoming these hardships to do what we want to do.
Well, let me tell our viewers, when I came in year 2000, and since then it has been said there is one scientist, Professor Ramnath Kaushik. He's been called Crazy Kaushik, and he's teaming up with Professor V.S. Ramamurthy, Secretary of the Department of Science and Technology then. So tenacious Ramamurthy and Crazy Kaushik brought Indian astronomy to this high height. Tell me the unique features of this lovely telescope we have behind us.
So this is a 2-meter class telescope, and it was built in 2000. It saw the first light in 2000. The most important thing is it's very concise. Like if you look at telescopes which are built around 90s or 80s, the telescope and the whole dome is very big, and you could do everything on the dome. But now the whole concept changed, and you need to have very little space so that the air within and the outside gets similar, so that you don't have any eddies and turbulence within, so that the image quality of the telescope is extremely good. So this is a very concise dome and telescope inside. The observing floor is very concise, and this also is extremely unique because when it was established in the first light saw in 2000, it took 12 hours to reach here from Leh, and this is extremely hard weather and hardship to come over here. Not everybody can come here. So one of the conditions put forward was that this telescope has to be remotely operated from Bangalore from day one. So we have achieved that, and we're continuing to do so. And I don't think in 2000 nobody actually had any idea how to operate a telescope remotely, but this is designed to do so. And all the instruments which you want to put on board are actually fitted together in an instrument cube, so that you can switch from one instrument to the other without much of a problem. And till today, the observers don't come here, but they go to Hosakote campus of Indian Institute of Astrophysics and take observations there. So the engineers here open up the dome and start all the instruments and give the control to Hosakote, and people over there take control of it, and then they take the data during the night time. During the daytime, the data is downloaded over here. So that is the most unique part of this particular facility.
Now,
but there are a lot of uniqueness about this observatory itself.
Let me explain that in simpler terms for our viewers. The telescope is here. It gets connected to India's satellites up in the sky. From there, it gets downlinked to Hoskote, where the Indian Institute of Astrophysics has another facility. So astronomers don't have to brave the cold other than Dr. Subramaniam, who needs to come to the site off and on again. But astronomers can remain in warm Hoskote, while engineers who monitor and run this telescope have to operate it from here. So a facility given to Indian scientists from year 2000 to be able to work comfortably from the warm environments of Karnataka while doing observations from the cold desert of Ladakh. Ma'am, what has been one or two of the fine findings from the Himalayan Chandra Telescope?
Yeah, so this telescope, the uniqueness of this facility is that this monsoon time, the clouds are not coming here, so that they stop from the lower ranges of Himalayas. So it is operational throughout the year. So because of that, events like the targets of opportunity, when there is an explosion in the universe, like a supernova explosion or a variable study of the Aegean, or even the multi-messenger astronomy where you have a gravitational wave event, so that those things can be immediately monitored from here. So this particular telescope has contributed to our understanding of this exploding stars enormously, and this has contributed to, of course, this is a smaller telescope, not a telescope of 10 meter size where you do major discoveries, but this played a major role in contributing to crucial data where other telescopes were actually down to getting the science out of it. So there are a lot of nature papers come out of understanding how a stellar explosion happens, what happens to the stellar ejecta, etc. And the other thing is, when you are looking at the exoplanets, the transit studies help you to understand how many planets are there. We know that the TRAPPIST system is actually like a solar system itself. So even that kind of transit studies, this telescope has contributed. It also has a very high resolution spectrograph. So we also use that spectrograph to take elemental abundances of stars. It is also, our students are right now studying about elemental composition which is absorbed by planets. Like when you have a star and a planet moving in front, the planet actually absorbs the light from the star. So you can actually study when the planet is not in front and when the planet is in front. So this high resolution spectrograph, which is in a stable environment, helps you to actually study those elemental abundances. Yeah.
Now, we get the stable environment for many reasons here. We are sitting in the Changthang plain, and here you have the Mount Saraswati. So how does the air and the stability give you better observing conditions? And tell me, how high above the Changthang plain is Mount Saraswati, where we are standing, and we can see the Changthang plains below us?
Yeah, so when you travel from Leh to here, overall you can see mountains on both sides. They rise, and you don't know what is after that. But then they just rising mountains you see. But when you reach here, you can there's a unique topology where there's a huge plain. It's a Changthang reserve, and you have a huge plain, and in the center of the plain there is a mountain.
That's why we can see the plain there, and this Mount Saraswati
is at the center of it,
uniquely sitting in between.
Yes. So you have the stabilizing environment around it, and then suddenly this mountain comes up, so it actually stabilizes the air which is flowing through it, so there's no turbulence coming in. So that's the unique reason of it. The base camp is somewhere around 4,200, maybe a little
Correct.
here and there, plus or minus tens. And this is about 4,500 meters above sea level. So this 300 meters gives you a good coverage of the, you don't have to, the mountains don't block our view, so that you can actually cover the entire east to west coverage of the objects.
The Himalayan Chandra Telescope is just one telescope here. There are other unique telescopes here, and it is a multi-institution facility. Dr. Subramanian, what can we see here in this dome here?
This is a 70 centimeter growth India telescope. This is put up in collaboration with IIT Bombay. So this telescope is basically a robotic telescope. So where you can actually upload all the directions the telescope should see during the night, and then you switch it on, and then it just does the entire job, and then by morning you get all the data. This does mostly the wide field photometric observations, in the sense of the imaging observations, and there are a number of studies coming out with respect to explosive stars, as well as some discovery of some asteroids.
So the Growth telescope is operated from IIT Bombay.
No, it is also operated from Crest campus.
So both campuses, these are remotely operated, but this is a telescope which we can look for stuff which HCT cannot do.
This is in the sense that HCT has a larger resolution in terms of angular resolution, and it can go fainter. This is a smaller telescope with lesser spatial resolution, so you can actually look at not crowded fields or single objects for its variability, and also asteroids which actually move across the field. This is also operated from Crest only. The data, whatever data has to go back to IIT Delhi, we push it out to IIT Delhi.
Now,
Sorry, IIT Bombay.
IIT Bombay is the
right.
collaborating institution with Varun Bhale Rao
Varun
as
Bhale
the person who is
Yes.
the principal investigator.
Yeah, so this is, I must also add that this project came through with collaboration with, or under the banner of Indo-US Science and Technology Forum. So this is a Indo-Caltech collaboration. So that is how it is set up.
Now, below Mount Saraswati, we also have some telescopes of the Department of Atomic Energy. Very quickly tell me about those.
Yeah, so we have this, initially we have the Hagar, which is high altitude gamma ray instrument, which was it's set up in collaboration with TFR and Embark. It's been operating for the last 12 years or so. It just observed how a lot of interesting objects actually. And after that, they thought that they need to have a bigger instrument to catch the explosive events up in the cosmos. And Mace telescope is designed, and they started putting it up. And as you know, construction over here is very difficult, so it takes longer time. Now it is working, and I mean, we saw the inauguration yesterday. So that is a very big facility down on the foothills of this mountain. And up in the mountain, we also have other instruments. Because this is a unique site to set up, understand the greenhouse emission.
It offers a pristine atmospheric environment.
Yes, and the GPS high
Geodetic
resolution.
class.
Yes, the GPS which you can actually measure the tectonic movement between Bengaluru and here. And we also have some instruments from the Space Physics Lab of ISRO. And a few more. IIT Roorkee has set up some radiometer, etc. So a few more instruments are up here. So these are smaller instruments, but they give focused, valuable data.
Now, in future, I am told the Indian Space Research Organization, which is already a partner with you, giving you connectivity, but they also want to set up a telescope for space weather monitoring and monitoring our
yes.
Satellites in space?
Yeah, so they are monitoring the debris in space. So that's called the space situational awareness. Correct. So they wanted to set up a telescope here, 1 meter class telescope, and it's going to come over in one of the sites here. And that is to image space debris and to predict where they are, and you also count to know how many over there. And this will be set up in a year's time. And they're also planning to put up a 6 meter dish for terahertz. Terahertz is a sub-millimeter range, and astronomers are interested in two things in sub-millimeter, where the shadow of the black hole was imaged in that particular wavelength, and also the molecules in the interstellar medium also emit in the sub-millimeter range, cold molecules. So that these two are important for astronomers, and terahertz receivers are also important for as technology development. So these are important facilities from ISRO coming up. So here, and as you can see, a lot of departments scientific departments are interested in investing here, as well as already they have invested quite a bit here and expanding that investment here. So there's indeed a mountain with knowledge. It's providing knowledge in various ways as well.
Now, behind the Himalayan Chandra Telescope, we can see a slightly higher ground which has been flattened out, and it has been flattened out with a reason.
Yes.
Tell me what is the reason for that, and when can we expect what
Yeah.
was supposed to be there?
So that is the peak. You can see that we are already monitoring that particular site. We have a that's the image motion monitor over there. And this site is identified for the large optical telescope. So when it was set up in 2000, the idea was to set up a bigger telescope, the 6-meter class to 8-meter class, in 2000 itself. Because the effort to put up a telescope in Ladakh started in 80s.
Wow.
Yeah, so then 80s, it became 90s, nothing was happening. That was one, our director Kaushik pushed it, and then people said that, okay, do a pilot study and put up a smaller telescope and prove that you can do it and you can actually run. It's not only setting up, it's running the facility, it matters, right? So we have done it for 25 years. Now it is time for us to scale up. So that's scaling up. Now we have the technology, understanding of the technology for multi-mirror telescopes. Like when you have to make to larger telescope, larger aperture size of the mirror, you don't make a monolithic mirror, but you need a segmented mirror. Now with partnering with the 30-meter telescope project, we have gained knowledge about the multi-mirror telescope. So segmented mirror telescope is what is planned, and that is one of the potential sites is behind this.
When do we expect that to happen?
The TPR is getting ready, and then once the project funding comes up, we'll start working on it. We have the know-how in the country, and the industry has understood to supply all the support systems, etc. The crucial parts we can make in the country itself, so we can actually make most of the things in the country itself for the telescope.
Well, for our viewers, it's not just science here which is happening. There is also a people connect, where first time I am seeing science being used as a tool for sustainable development for the local population. The Indian Institute of Astrophysics, especially with the work done by Mr. Dorji Angchuk, they've been able to set up what is called a Himalayan Hanle Dark Reserve. What is this Hanle Dark Reserve, ma'am?
Yeah, so this is a very remote place. So people over here, there are about 5 villages, and they don't have any kind of a sustainable income, and also the kind of education they have, the exposure they have is limited. So the sky is very beautiful. That's our resource here. So we should use that resource to make their life better, make their education better, so that it's the science can provide to community directly touch their lives. So we introduced something called astro-tourism here, and Dorji Angchuk, our engineer in charge, is a very well-known astrophotographer. So those photographs are really stunning photographs of the sky taken from here. So that helps people to understand that you can come here and you can take this wonderful photographs of the dark sky. So we working with the UT Ladakh administration and also the Hill Development Council to set up this dark sky reserve, so that the scientific experiments can continue without light pollution, and by controlling the light pollution, people can come here and enjoy the night sky. And as we were discussing, it's already a wildlife reserve, and there are a lot of wild species over here. There, and flora and fauna, their preservation also happens. So the cognizance of coexistence that happens here. So we actually in 2022 June we had an MOU, and in 2022 December, this area, 23-kilometer radius centered around this mountain, was declared as a Hanle Dark Sky Reserve. Now we are carrying out the light management plan, and also we are setting up a gate. We are actually partnering with the administration to provide them technical help. The funding is coming from the administration for the benefit of the people out here. And we have trained about 24 people from the villages with about 17-18 women to how how to explain the sky to visitors, and we've given them telescopes, and they also know how to show the people the telescope. So actually when the tourists come there, they don't come to the observatory to see the night sky, they go to the astro-tourism ambassadors, and they explain to the people. So by them the economy is also benefiting. So we hope to have a coexistence and economically viable situation here. It's a very crazy idea of how you use the astronomy to the benefit of people.
Absolutely amazing idea, and how sustainability can be brought to the livelihoods of local people, and how sophisticated scientific instruments can help boost the local economy in a very remote part of India where there is still no grid connectivity, so there is no electricity directly coming from the grid. The internet is intermittent, so anything which is done here is very tough. This is also a location where science and spirituality meet,
Yes.
because we have a 400-year-old Gompa which is there, and the Lama there is also an astro ambassador.
Yeah. Yes.
How do you combine the two, ma'am?
See, it is the same mind which is analyzing the science as well as spirituality. So people find a way to connect it. They are happy to connect it. But it's like, looking for something which you don't know. It's venturing into the area of unknown, right? Both the things have the same principle of, or same focus of getting to know the unknown. So I believe it is possible. And yeah, so he's current Lama is one of the astro ambassadors, and he's happy to do both the sites. It's really, really brilliant.
So there you have a discussion standing at Mount Saraswati, 4,500 meters above the sea level. The sun has come out. It's a little warmer now. We started off at very cold conditions, but this site offers India and the world a very unique eye in the sky. You can literally touch the stars here. The Milky Way seems well within reach. I was part of a star party here. In cities we hear of rave parties, we hear of dance parties, but astronomers have a different way of celebrating the universe with a star party. And with astronomers like Dr. Subramaniam, they celebrate stars all the time. Thanks a lot for speaking to me, Dr. Annapurni. I'm sorry I pushed you so hard in the early morning, but this unique location offers one of the finest places to understand the secrets.
Yes, we have been awake to catch the comet, but it was very close to the sun already. Yeah, right. Thank you so much.
So, deciphering the secrets of the universe, understanding the mysteries of the solar system. After all, we are all made of stardust, and this telescope offers a wonderful view of stars, a unique Indian facility. With camera person Rohit Vishkarma in the freezing conditions of Hanle, Ladakh, Pala Bagla for NDTV.